it's called the index. Have you ever heard that before? The index. So that number is like what root you're taking. The square root would mean you have an index of 2, right? So when it's just something like this, there's like a little imaginary 2 there that's not actually there, but we assume it to be 2, okay? But if the index is 3, you're taking a cube root, right? So there's square root, there's cube root, there's 4th root, there's 5th root, 6th root. You just keep going up by number. Basically what that's saying is what number times itself this many times, or what number times itself that many times is going to get you to where we're trying to go. Okay, so a second root would be a square root, a third root would be a cube root, and then beyond that you just say the number. Anyone know what we call this guy?
Radical.
It's the radical. That symbol is your radical. Okay, and then anyone know what you call the thing under the radical? The what?
The number.
It will be a number. It's called your radicand. Okay, radicand with a D at the end. And then this just says if there is no index. So if there's no number written there, if it just looks like this, okay, that would be, there's no index here. If there's no index, we assume that that n value is always 2. So if there's no number written in, it's a square root. If there is a number written in, then you use the number that's there, okay? So we're going to be living in the positive root for these. We're going to be talking about the principal root. That's going to be the positive one. Remember, the square root of 4 could be -4 or +4. We're going to be just dealing with the positives of these, okay? So a +4, yeah, the positive number is what we're working with. Okay, can anyone tell me the very first perfect square?
4. 2.
Well, yes, the one that we've been starting with is 4. 4 is 2 times itself, right? 2 times 2. So which one would come before that, technically?
2.
Not 2. 1. 1 times 1 is 1. So if we are truly listing the first perfect square, it's 1. Now, 1 never comes into play with what we're going to do today, but it is technically the first perfect square, 1 times 1. What's the next perfect square? 4. The next one? 9. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. I'm writing too big. That's going to be the struggle for you guys now too, huh? Can't zoom in. So the list of the perfect squares, that would be the first 12, up to 12 times itself, 12 squared, okay? What we're going to be doing is taking square roots, sometimes that are perfect, sometimes that are not. And again, this is not new. You guys have done this. So this should be pretty straightforward for the most part. What is the square root of 16? It's 4. You're saying what times itself gets you 16, right? What times itself? 4 times 4 is 16. Okay, so then look at number 2. This is 2 times the square root of 121. Can you tell me the square root of 121? It's 11. So really this is saying 2 times 11. And you will get to use your calculator on all of this. So you can just plug in the square root of 121. Your calculator will say that's 11, but then you got to remember to multiply them. So 2 times 11 is 22. Okay. Look at number 3. Anyone know the square root of 289? Huh? How'd I get what?
No, because
Wasn't 289?
Are you sure? You good?
yeah, because I saw like I thought it was like a 2.11.
Oh, this is a times. Yeah, sorry. 2 times 11.
Isn't 289 17?
17. Yeah, the square root of 289. So again, plug it into your calculator. The square root of 289 is 17. So this is 6 times 17. Okay. Let me just tell you where I usually see the mistakes on this one. People see these two numbers, the 6 and whatever the square root is, and they add them together instead. This is multiplication. 6 rad 289 is 6 times the square root of 289, okay? So you're going 6 times 17, which is 102. And again, your calculator will do that for you. Just type in 6 times 17 once you figure out that the square root of 289 is 17. Yes.
Could it just do 6 rad 289?
Yes. Yeah. When it's a perfect square, you could just plug it in like that. When it's not a perfect square, you won't be able to. But yes, on a perfect square, you can. Anyone know what the square root of 400 is? 20. So this is 3 times 20, or 60. Okay. Okay, so those are the lovely ones where you can just plug something into your calculator and it does the work for you. Where it's not quite as lovely, and I need you to get your calculator out for this. So if you don't have a calculator out right now, get a calculator out. We're going to be breaking down these radicals into simplest radical form, is what we call it. And here are the steps for doing that. And I'm just going to walk you through and make sure that we're comfortable with this again. Starting with the square root of 32. So here's your list of perfect squares. You're going to take that 32 and you're going to think, what is 32 divisible by that is a perfect square? So if you look up here, 36 is too big. So you wouldn't even start anywhere past that, right? So start high and work your way down. 32, is it divisible by 25? So you go 32 divided by 25. Does that work? No. 32 divided by 16? Yes. Now here's the issue. What if we had started from this side? What would you have found? You would have found 4. Okay, so let me show you something. If you use the 4, it's not wrong. It's just not fully right yet. Do you know why? It's not simplified. So you could use 4 and 8. And if we did that, don't write this down because this isn't what I want you to do, but I'm just showing you a second way it could happen that you could still get there. Now you're at this, okay, 2 rad 8. The square root of 8, you can simplify to 4 and 2. So it's 2 times the square root of 2, which would be 4 times the square root of 2, okay? But if you do it the right way, the better way, you would get this. This is what I want you to write down, okay? You're doing 16, and 16 times 2 gets you 32. Whichever one is the perfect square, you take the square root of. So the square root of 16 is what? 4. The square root of 2 we can't do anything to. So you get 4 rad 2. Notice they're the same answer. This one required a lot more work. So if you don't find the highest one first, you just have a bunch of extra work to do, okay? So look for the biggest one and then go from there, okay? All right, so look at number 6, 180. Where do you think you would start dividing? 180 divided by what? 100, okay? Try 180 divided by 100. Does it work? Shouldn't work, right? Try 180 divided by 81. 180 divided by 64. Let me know when you get to one that works. Did you get one? 36. Did you get 36? If you take the square root of 36, when you plug that in, 180 divided by 36, you get what? 5. That's the non-perfect square, okay? So that's always going to be the one that goes on the right. You're going to put the perfect one on the left because that's the one that's going to ditch the radical eventually. You're going to put the one that is not perfect on the right. Okay? So from here, now you take the square root. The square root of 36 is 6. The square root of 5 we can't do anything to, so that's going to be your answer. Okay, so you're just breaking things down into simplest radical form. Okay, here's what we're going to do. I want you to try 7 through 10 on your own right now before we jump to the next thing. So give 7 through 10. What did you do on 7? What perfect square? What goes on the left? 49. Do you understand that this is still a radical, right? 49 and what? 3. If I'm saying the square root of 147, yeah.
Wait, does it matter if it's on
No, but yes. It's definitely going to benefit you if you put the perfect one on the left, because what happens is if you always put the perfect one on the left, that's always going to be the one that eventually ditches the radical, right? And that's what you want to put out in front, is the number that doesn't have a radical. So like the square root of 49 is 7. The square root of 3 is going to keep the radical. But if you did it this way, the square root of 3 and the square root of 49, then you have the square root of 3 times 7. And that's not the format that you write it in. So then you have to rewrite it as 7 root 3, because you always want the whole number first and then the radical. So it's just a good practice too, because you're always going to ditch that square root symbol. So if you always put the perfect one on the left, then you know which one to get rid of every time. Good on that one? 7 root 3? Okay, what'd you get for number 8? What's your final answer? 5 root 7, 5 times the square root of 7. So again, if you do the perfect, what perfect square was 175 divisible by? 25, yeah. So you would put the 25, the perfect one on the left. 25 times, was it 6? Nope, 7. I lied. So take the square root of 25, right? The square root of 25 is 5. The square root of 7, we can't do anything to, so that keeps the radical. So you're always going to ditch the radical of the one on the left. Does that make sense? All right, what'd you get on 9? What perfect square is 48 divisible by? 16. So that goes on the left. Times what? 3. So that becomes, how do you simplify that? 4 root 3. Okay. Okay, 10 is a little bit different because there's one last step at the end that you have to make sure you do. What do you do first here?
To find out what 54 is.
Yeah, so I would bring the 2 with you so you don't forget about the 2, because usually that's what happens is people forget that there was a 2 there to start, and then they forget to multiply by it. So bring the 2 with you the whole time. 54 is divisible by what perfect square?
27.
Did you find it? So 27, it is divisible by 27, but 27 is not a perfect square. It's actually a perfect cube, which we're going to do in just a minute. But it's not in your list up here, right? So we're trying to figure out 54 is divisible by which of these? It's the 9. The 9 is the highest one that you can do. So you put the perfect on the left. 9 times what gets you 54? 6. Okay, so then if you take the square root of that, the square root of 9 is 3. And you still have this 2 here, and then you still have the square root of 6. What operation is happening between the 2 and the 3? It's multiplication. If it's a number next to a radical, that's assuming multiplication. So make sure you don't add those. It's not 5, it's 6 instead. So multiply that, you get 6 times the square root of 6. Okay. Any questions on that? Okay, let's just do one more from this next chunk of 4. Let's do number 13. Sure, let's do 13. So you have a -3 out in front, so bring that 3 with you, that -3 with you, and then you want a perfect square and a non-perfect square. What is 28 divisible by from this list? It's the 4. Okay, so 28 is divisible by 4, so that's going to go here. 4 times what gets you 28? A 7. Okay, so now you're here. What's your next step? Simplify what? The square root of 4. What is the square root of 4?
2.
It's 2. So if we call that 2, this is still the square root of 7. This is still a -3. What do you do with that -3 and 2?
Multiply it.
You multiply them.
Number 6.
So you get -6 times the square root of 7. Okay? So simplest radical form. Hopefully that doesn't really feel new to you because we've done this. What will feel a little bit new is dealing with perfect cubes. Okay? Tell me what a perfect cube is. Like what are we doing to get to the perfect cube number? Multiplying by what? You're not multiplying by 3.
By 2.
You're not multiplying by 2.
Itself.
itself 3 times, okay? And I think that's where the confusion happens. You have to multiply by itself some number of times. So a perfect cube means multiply by itself 3 times, okay? So if we list the first 10 perfect cubes, what is 1 to the 3rd power? 1. 1 times 1 times 1, right, is 1. So your first perfect cube is 1. Then you jump up to 2. 2 to the 3rd power, so 2 times 2 times 2 is 8. 2 times 2 is 4, times 2 is 8, okay? So 1 and then 8. The next one is 3 times 3 times 3, which is 27. Side note, I feel like those 3 show up the most. Those 2 show up the most. 1 really doesn't happen. This one shows up a fair amount. 4 times 4 times 4 is 64. 5 times 5 times 5 shows up a fair amount, 125. And then beyond that, we don't do a ton with these higher ones until we get to 5 or to 10 cubed is one that shows up again. So this is 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And then 10 cubed, 10 times 10 times 10. How many zeros do we need? 3 zeros. It's 1,000. Okay. So that one, I mean, maybe shows up a little bit more than some of the others, but yeah. Okay. There's something a little bit different on this one. Can you take the square root of a negative 16 as we know it right now? No, you cannot take a square root of a negative because there is no number that when you multiply it by itself will get you a negative answer until you get to algebra 2, and then I'll teach you about imaginary numbers. But for right now, we are only working with real numbers, okay? So this one you can't do. Can't take the square root of a negative. Can you multiply a number by itself 3 times to get a negative? A number times a number times a number, can that be negative? Absolutely. A negative times a negative is positive, times a negative again is negative, okay? So if I am taking the cube root of something, sorry, I left that as a square root, I can do negatives now, okay? So that's where it's a little bit different with this. If the number underneath is positive, your answer is positive. If the number underneath is negative, your answer is negative. If this is a 3, okay, for cube roots. Can anyone tell me what the cube root of 8 is? It's not 4, it's 2. What times itself 3 times will get you 8? Get your calculator out. I'm going to show you how to plug that into your calculator so that you don't have to know it. What?
Trying to do it, it wasn't working.
Yeah, it's not a square root, it's a cube root. And you know what? My calculator is different buttons than yours.
There's a carrot. This one.
Yes, yeah. So here's what you're gonna plug into your calculator to check these, okay? You're gonna type in a 3, because that's gonna be the cube root. And then you're gonna hit second. And then you're gonna hit the caret button because right above it is this little X radical, okay? So basically what we're saying is we're dropping a 3 into that. And then you type in negative 27 and hit enter. What? Negative 3.
I got an error.
Yeah, same.
Did you do a negative or a minus? Oh, yeah, you did a minus. Use that button, not that one. If you got error, you probably use the minus instead of the negative. The negative is the one like this, next to the decimal point. Yeah,
I have a different calculator.
let me see. Oh, it looks like yours does a cube root, so you'll just go shift. And then the same square root button, to see if it says square root 3, that means cube root. So you just go shift and then that button, and it will do a cube root for you. Okay, so anyone not? Math 4. Am I right?
Oh, yeah.
Yeah, math 4. Okay, so on this then, the cube root of negative 27 came out to a negative 3. That's your answer. We're saying negative 3 times negative 3 times negative 3 is a negative 27. Okay, cube root of negative 27. Can you tell me what the cube root of 343 is? Plug it into your calculator.
It's not working.
It should.
Okay,
It's
that's
here.
3.1. Oh.
It's impossible.
I got to 3 something.
It should be 7. You should be typing in 3, and then second, and then the caret, and then 343. Try that. Did you get 7? 3, second, the caret button, 343, enter.
Oh,
7.
it's because I put the 5 next to it.
Oh yeah, no, evaluate it first and then do the multiplication.
So does that make that 5 times 7?
Yeah, so you will evaluate this as 7, and now this is getting multiplied by that, so 5 times 7 is 35. Okay, tell me what you get on 18 then. Plug that into your calculator. And again, don't plug the 2 in yet. Leave the 2 alone. Just evaluate the cube root first, and then do the multiplication. So this should be 10 times something. What's that something? What is the cube root of negative 1,000? Negative 10. So you should be doing 2 times negative 10 or negative 20. Okay?
Wait, I have a question.
Yeah.
For the last, you said we couldn't square root negative numbers, so why can we square root negative numbers now?
You're not. You're cube rooting negatives.
Okay.
So you can't square root negatives, but you can cube root negatives because a negative times a negative times a negative is a negative, right? But a negative times a negative can never be negative. That will always be positive. Yeah. Okay, I'm going to do the first couple with you, and then I'm going to have you try a couple on your own. So this is similar to what we just did with simplifying square roots, but it's cube roots now, okay? So you really have to pay attention, like when we get to the quiz or the test, you have to pay attention to that. If there is a number there, it's a cube root. You're looking at this list. If there isn't a number there, if it was this, then you're looking at this list, okay? And I think that's probably the trickiest part of all of this is just making sure you're using the right numbers to divide by, okay? So take a look at this. We do not want the square root of 40. We want the cube root of 40. So you're gonna say a perfect cube and a not so perfect cube that 40 can multiply to. So take a look at your numbers. 40 is not divisible by 64. Is 40 divisible by 27? No. Is 40 divisible by 8? It is, okay? So that's what you're gonna put here. The cube root of 8 is a nice whole number. God bless you. 8 times what gets you to 40? 5. Okay, so do you see the process? It's the exact same as what we were doing with square roots, but you're using different numbers, okay? What is the cube root of 8? You may plug it into your calculator, or maybe you just know it off the top of your head now. The cube root of 8 is 2. The cube root of 5, we can't do anything to. So you just get 2 cube root 5, okay? Yeah, Jim.
How do you make the list? Like the,
Make the list.
yeah, the list right above.
This is 1 cubed, this is 2 to the 3rd power, this is 3 to the 3rd power. So you can, like, if you don't know those numbers, you can just plug them into your calculator. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. Or you can do 2 caret 3, right? That would get you this. So it's always the number times itself some number of times. Perfect cubes is 3 times. Perfect squares is 2 times. Okay. Okay, go to number 20. Your number is 192. So you're going to go up here and go 192 divided by 125. 192 divided by 64. And divide until you find a number that works out to a whole number when you plug it in. 192 is divisible by which of these? It's 64. Okay, so if you type in 192 divided by 64, you get what? 4. No,
No,
3. 3. The cube root of 64 is 4, yes. Okay, so 64 times 3 is 192. So we're just breaking that perfect cube into two separate, sorry, it's not a perfect cube. We're breaking that cube root into two separate cube roots of equal value, okay? So if I'm multiplying these right now, I can simplify the left side because your left side will be the perfect one. What is the cube root of 64?
4.
It is 4. The square root of 64 is 8. The square root is 8, right? What times itself twice? This is what times itself 3 times gets you to 64. So 4 times 4 times 4. And again, your calculator will do it for you. Type in the cube root of 64 and your calculator will tell you that's 4. So you get 4 and then the cube root of 3, which we can't break down. So that's your answer. Okay. All right, go to this one. This one has a 2 out in front. So it's going to be 2 times a perfect cube and something that's not a perfect cube. So you go 432 divided by, and pick where you want to start, but start high and work your way down. What is 432 divisible by? 216. Okay, so from that list, 216 is the highest one that works. 216 times what is 432? That's 2. Okay. Okay. Now you have 2 times, what is this equal to? The cube root of 216. That should be 6. Again, that's something you can plug into your calculator. The cube root of 216 is 6, and then you have the cube root of 2. So now you can multiply those whole numbers. 2 times 6 is 12 times the cube root of 2. And that's your final answer. Questions on that? Okay. I want you to try 22 and 24 right now. Give those a go. So just remember, you're going back to this list up here and plugging in what is 250 divisible by from that list. Okay, did you find it? What's 250 divisible by? 125. So the cube root of 125 and the cube root of what? Sorry, make this one negative. So negative 125 and positive 2. We don't want to leave negatives under that, so you want to keep the negative with the perfect. So cube root of negative 125, and you have this negative 2 out in front. So this is negative 2. What is the cube root of negative 125? Of negative 125. You put the negative in, and it told you 5?
Yeah, yeah, see?
Yeah, it's 5.
Negative 10.
Oh, you put a negative out in front. Don't put the negative out in front. Cube root of negative 125 is what?
I thought it was negative 2.
No, you want to put the negative with the perfect one so that we can, because we don't ever want to leave negatives under our radical.
So it's just positive.
Is it not 5?
It's 5, but it's like.
Are you typing this into your calculator?
Mm-hmm.
The cube root of negative 125.
So it's just negative 5.
What?
Yeah.
Negative 5.
It's negative 5.
Oh.
It's -5. When you plug just this into your calculator, it should tell you -5. Does everyone have that now?
So double negative?
Put the negative here, the cube root of -125, but don't put this out in front yet. Just evaluate the cube root for now. Okay, so you still have the cube root of 2 here, and then you multiply this, what do you get? A +10 times the cube root of 2. Okay,
I still got that without.
because you plugged the whole thing in.
Oh,
My question was, what is the cube root of -125? So that's where I was looking for a negative
oh.
on that. Okay, what do you get for the cube root of 189?
27,
Is it perfect?
27 and 2.
27 and 2, yeah, 27 and 7 would get you there. So 27, right, 189, so you're looking back up at this list and going, what is 189 divisible by? The first thing it's divisible by is 27. So 27 times 7, and then you simplify. This is -3. What is the cube root of 27? What times itself 3 times? Gets you 27. 3. So you get, oops, not equals there. Let's do this. A -9, and then bring down your cube root of 7. Okay?